All right, today we're going to look at section 9.4, something called limiting reactants. We're going to be able to identify a limiting reactant when we're given the quantities of two reactants. And then we'll be able to calculate how much product is formed. A limiting reactant in a chemical reaction is the substance that runs out first. So we're going to use up that reactant first. It will stop the reaction. It produces a smaller amount of product, kind of like golf, low score wins. So lowest product is the limiting reactant. And it limits the amount of product that can form. So thinking back to our sandwich activity from last week, thinking about the sandwiches, and we make peanut butter sandwiches. For example, 2 slices of bread and a tablespoon of peanut butter for our sandwich. So we can write an equation, 2 slices of bread, 1 tablespoon of peanut butter produces or yields 1 peanut butter sandwich. I want to know where the jelly is, but that's okay. So how many peanut butter sandwiches could be made from 8 slices of bread and 1 jar of peanut butter? Well, with 8 slices of bread, we could make 4 sandwiches, and we run out of bread. There's peanut butter left over, but what limits the amount of sandwiches we can make is the amount of bread. So the bread is what we term the limiting reactant. Conversely, if we had 8 slices of bread and only 1 tablespoon of peanut butter, now we can only make 1 peanut butter sandwich because we only have enough peanut butter for 1 sandwich. So peanut butter is now our limiting reactant, and we have bread left over. The same thing applies in a chemical reaction. The reactants in a chemical reaction do not always combine and are not in the same proportion, and so that means they don't always get used up at the same time. So in most reactions there is a limit on how much product can be formed. So if we know the quantities of reactants, we can then calculate the amount of product that is possible and figure out which one is the limiting reactant. And that limiting reactant is the one that runs out first, producing a smaller amount of product. So just like in the sandwich activity online that we did last week, here we have carbon monoxide and hydrogen used to produce methanol. And here's a balanced equation for that. It says here 3 moles of carbon monoxide and 5 moles of hydrogen are 2 reactants. What is the limiting reactant and how much methanol can be produced? Well, anytime you're given the amounts of 2 reactants, we have 2 reactants, we have to first find the limiting reactant. So we know what we're given, 3 moles of carbon monoxide and 5 moles of hydrogen. We need to find the limiting reactant and figure out how much methanol can be produced. So we have our balanced equation. We're going to take moles of carbon monoxide and use our mole factor to get us to moles of methanol. And then we're going to do the same thing with moles of hydrogen, using a different mole factor to get us to moles of methanol. And then we'll compare the 2 amounts of methanol to figure out which one is the limiting reactant. So looking at the balanced equation, I see that carbon monoxide, the coefficient is 1, and methanol is 1, so that's a 1-to-1 mole ratio. And then the hydrogen is 2 to 1. So if I'm looking at my balanced equation here. I've got 3 moles of carbon monoxide and 5 moles of hydrogen. I'm going to then look at the two amounts. So starting with 3 moles of carbon monoxide, I'm trying to find moles of methanol. So the unknown, that's on my unknown, so that's going to go on top. So 1 mole of methanol over 1 mole of carbon monoxide. So my carbon monoxide moles cancel, and I'm going to make 3 moles of methanol from the carbon monoxide. Then I'm going to do the same thing for the 5 moles of hydrogen. So I have 5 moles of hydrogen. This time I'm going to use my hydrogen mole ratio. I'm going to still put methanol on top. That's still my unknown. And then I'm going to put, this time, 2 moles of hydrogen, because that's the coefficient for in front of hydrogen. Looking then at my units, moles of hydrogen cancel, and I'm going to take 5 and divide it by 2, and that gives me 2.5 moles of the methanol. So the question then becomes, which one is the limiting reactant? Well, which one produces the least amount of methanol? So here is my least amount of methanol, so my limiting reactant is hydrogen. So a hydrogen is limiting, and it produces 2.5 moles of the methanol. Oftentimes, the quantities of reactants are given in grams. That's how we measure in the lab. So that's the more common way we'll be seeing the amounts in grams. So the calculations work the same way. The first time we need to take grams, convert it to moles, and then moles of product using a mole ratio, and finally to grams of product. Again, we're going to select the smaller mass of product, which is from the limiting reactant. So here's our problem. So silicon dioxide, which is sand, and carbon are heated. The products are silicon carbide and carbon monoxide. So silicon carbide, it says, is a ceramic material used as an abrasive and in brake discs. So the question says, how many grams of carbon monoxide are formed from 70 grams of silicon dioxide and 50 grams of carbon? So I have, because I'm given the amounts of 2 different reactants, I'm going to have to use 2 different equations and find the amount of carbon monoxide. And so now I'm going to take my 2 amounts, 70 grams of SiO2 and 50 grams of carbon, and I'm going to do 2 stoichiometry calculations and find grams of carbon monoxide for each. Then we'll look and see which one gives the least amount of carbon monoxide, and that is our limiting reactant. So let's begin. I'm going to start with the 70 grams of SiO2. And I'm going to do the molar mass of SiO2. That's 1 silicon and 2 oxygens. So 1 mole of SiO2 is 60.09 grams. So then that grams of silicon dioxide cancel, leave me with moles. I'm trying to get to grams of carbon monoxide, so I'm going to use my mole-to-mole ratio. I'm going to put carbon monoxide, that's my unknown, it's going to go on top. So because it has a 2 coefficient, we're going to put 2 moles carbon monoxide and 1 mole for 1 coefficient for SiO2. So now I have moles of silicon dioxide cancel, and I have moles of carbon monoxide as my unit. So the last step is to do molar mass of carbon monoxide. So I'm going to do the molar mass of carbon monoxide, 1 carbon and 1 oxygen. So that gives me 28.01 grams of carbon monoxide in 1 mole. Moles of carbon monoxide cancel, and I wind up with, try that again. I wind up with 65.3 grams of carbon monoxide if I use up all of the 70 grams of SiO2. Now I'm going to do the same thing, but this time I'm going to start with the 50 grams of carbon. So I'm going to do 50 grams of carbon. First step is going to be molar mass of carbon, because I'm converting grams of carbon to moles of carbon. So 1 mole of carbon is 12.01 grams. Grams of carbon cancel, of course. Now I need the mole-to-mole ratio for carbon and carbon monoxide. So I'm still putting carbon monoxide on top. That's still my unknown. So 2 moles of carbon monoxide over 3 moles of carbon. Moles of carbon cancel, giving me moles of carbon monoxide. Now the last step is going to be exactly the same as it was on top. So we're going to just have 28.01 grams of carbon monoxide in 1 mole. Moles of carbon monoxide cancel, giving me grams of carbon monoxide. So I'm going to divide by 12.01. Make sure you times the 2 on top and divide by the 3, and then multiply by 28.01. And we're going to wind up with 77.7 grams of carbon monoxide. So which one is my limiting reactant? Well, which one makes the least amount of carbon monoxide? That's this one. So I'm never going to get up to 77 grams of carbon monoxide because the SiO2 is my limiting reactant. So my limiting reactant is the SiO2, and I'm making 65.3 grams of carbon monoxide. And that's it. That's how you find limiting reactant. So we're combining what we learned in section 9.3 about stoichiometry and gram to gram conversions, and we're applying it to the idea of limiting reactants.